Today we are going to continue from where we stopped in the last class. So we are going to be looking at some questions on the quadratic equations and also approximations. So I want to believe you guys are ready for today's class. Okay, so don't forget, get your writing materials ready and get set for the class. And you can as well inform your classmates, let them know the class have started. So as you are joining the class, ensure you tap the like button. And if this is the first time you are joining us on this channel, ensure you subscribe to this channel if you love what you are doing here. All right, so we are going to wait just for a few minutes to see a good number on the platform before we commence the class. Thank you. All right, you're welcome to class. You're welcome to class. Darasimi, you're welcome to class. Okay. Yeah, if you are just joining the class, just say hi so we know the number of those that are in the class. Okay. All right, I'm seeing another person joining the class. Ayomide, you're welcome to class. Okay. Okay, once again, I welcome you all to today's class. Okay, just like I've rightly said, so I have some questions and I've penciled down under quadratic equations and approximations that we are going to consider today. So I want you to sit back and get your writing material ready. And as usual, today's class is going to be interactive. Okay, so don't forget to always drop your thoughts about the class. Okay, so now let's swing into action. The first question we have here is under factorization of quadratic expression. So we want to learn how to factorize this. Okay, so now let us see. Now the question given here, you have to factorize 2x squared y squared plus xy negative 6. Now, to factorize this, the idea is to divide this xy into two parts so that we have 4 terms here. All right, so that will make us now to look for the sum and product of this quadratic expression. Okay, so the sum is the coefficient of xy, and that is plus 1, while the product is the multiplication of 2 and negative 6. That gives us what? Negative 12. All right. So now we need two numbers such that when we multiply together, you have negative 12. And when you have together, you have positive 1. Now the two numbers are factors of the product. Okay, so you begin to think of factors of the product, that is negative 12. Okay, we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Okay, so now among all these numbers listed, so you look for two numbers that the multiplication gives us negative 12, the addition gives us what? Plus 1. So what are the two numbers? So we have plus 4 and negative 3. Now let's consider this. These two numbers are factors of negative 12. So when you multiply these two together, you have negative 12. When you add these together, you have positive 1. So the two numbers are positive 4 and negative 3. It's okay. So we are dividing this middle term into 2. Okay. So this expression turns to 2x squared y squared positive 4xy negative 3xy negative 6. Now, this middle term is the same thing as positive xy. All right, so now let's look at the first pair. This. Now, we locate the GCD of these two. All right, the greatest common divisor. All right, let's look at the number. So we have 2, we also have x, and we have y. Now, this can completely go here and can completely go here. All right, so when you divide 2x squared y squared divided by 2xy. So what do we have left? We have xy. Okay, 2 will have cancelled 2. So x will cancel 1x. So we are left with 1. Okay, x. So y cancel 1y. So we are left with 1y. So when you divide this by this, you have plus 2. Okay, so now let's look at the second pair. Now, what is the GCD here? That is negative 3. Negative 3 can go here, negative 3 can go here. So we have negative 3. So when you divide negative 3xy by negative 3, you have xy. And when you do the same thing to negative 6, you have plus 2. Okay? All right, so you can factor out what we have in the brackets. So when you factor out, we have xy plus 2. Now you are left with these two terms. So we have 2xy negative 3. And this is the answer to the problem. All right, okay, I want to believe you get that. Okay, so let's move down to another question now. This question now is going to be under quadratic equation. So this is quadratic expression. All right, okay. The second question is this: solve 25z squared equals to 9. So how do we do this? Now the first thing is to transpose 9. So we have 25z squared minus 9 equals to 0. Okay, so you can see this is a perfect square, this is also a perfect square. 25 is a perfect square, 9 is a perfect square. So now let's express this left hand side as 5z raised to the power of 2 minus 3 raised to the power of 2 equals to 0. All right, so looking at this, does this one sound something strange or something common rather? Okay, now when you look at this in mathematics, this is what we call difference of two squares, the subtractions of two squares. Now when you have x squared minus y squared, the result is x minus y, x plus y. Okay, just subtract the base, the two bases from each other and also add together, put them in brackets. So we are doing the same thing here. So we have 5z minus 3 times 5z plus 3 equals to 0. Okay, so that's what we have. So we have two numbers multiplying each other. So it's either this is 0 or this is 0. Okay, so we have 5z minus 3 equals to 0 or 5z plus 3 equals to 0. I hope you understand that. So the next thing is to add 3 to both sides of this equation. So we have 5z equals to 3, or now we subtract 3 from both sides here. We have 5z equals to negative 3. Okay, so the next thing, we divide both sides by 5. So we have z equals to 3 over 5, or z equals to negative 3 over 5. Okay, so these are the values of z. Okay, I want to believe you understand that. All right, so we are moving down to another question under quadratic equation. Okay, now this is another question. Right. I want you to pay attention to the explanation, to the solution of this problem. And before we solve this problem, if you are new in this channel and you love what we are doing here, so don't forget to subscribe to this channel, and also don't forget to also tap the like button. Thank you. All right. So now look at it. Now, when you look at this equation, it doesn't look like a quadratic equation. So, but the first thing is to find a way of clearing the fraction. So by the time you clear the fraction, then you will know the type of equation it is. Okay, let's look at this. Now, you can transpose this. Let's transpose negative 3. So to this side, so this turns to positive 2. So we have this to be x over x minus 3 minus 8 over x equals to 2. Okay. Now, the next thing is to find the LCM of the denominators. So what is the LCM of the denominators? And this one is also the same thing as over 1. So the LCM of x minus 3, x, and 1, okay, is going to be x times x minus 3. That's going to be the LCM of the denominators. Okay, so LCM is x times x minus 3. All right. Okay, so now the next thing is to multiply each of these terms by LCM of the denominator. Okay, the LCM will multiply this, and this. Can we do that? Okay, so we have, and when you use this to multiply this, you'll be having x times x minus 3. Okay, everything all over x minus 3 minus 8 times, okay, this dot means times x minus 3 over x, and the last one we have here, we have equals to 3 times x minus 3. Okay, all right, so I think this is 2, not 3. So that's 2 over 1. All right, so now let's see. This will cancel this. So let's cancel this out. This cancel this, and also x, we cancel this x here. So then what are we left with? So x times x is x squared. So we have x squared minus, now look at this. This is minus 8. We have to be very careful here. This 8 is attached to this negative. So we have negative 8 multiplying x, and negative 3. So negative 8 times x, that gives you negative 8x. Then you pick it again, negative 8 times negative 3. That gives you positive 24. Okay? So now let's move down here. The equality sign, we have, this is 2x because 2 times x is 2x. So 2x times x, that gives you 2x squared. Okay? Now this 2x now times negative 3. That gives you negative 6x. All right. Okay, so what is the next thing? We'll try and collect the like terms. So we have, let's move everything here. 0 equals 2x squared. Now when you move this one here, we have negative x squared. Okay, we have negative 6x. This gives you positive x. And this gives you negative 24. Okay, so now let's tidy up what we have there. So we have this 2x squared minus x, that is 1x squared. Now negative 6x plus 8x, that is going to give you plus 2x. And we have negative 24. Okay, now this time around I want to engage you. You have been watching me since. Okay, so what are the two numbers such that when we multiply together, we have the sum, and when we multiply together, we have the product, and when we add together, we have the sum. Okay, let me write out the sum. I want to believe every one of you know that the sum is 2, while product is negative 24. Okay, so can you do that and drop your answer in the comment section? So what are the two numbers which when multiplied we have negative 24, when added together we have plus 2. All right, so I want you to drop your answer in the comment section. Let me see what we have here. Okay, all right, I can see Joseph. We have plus 6, negative 4, plus 6, negative 4, plus 6, negative 4. Mudupe. Okay, Kulia, I know, I can see your result. Uber, yes. Okay, Pamela, Lydia, I can see your answer. Progress, I can see your answer. Okay, Abbas. Oh, Nabila, okay. Motunayo, okay. All right. Okay, so it seems everybody have the same answer. So let's see the validity of that. So we have negative 4 and positive 6. That is what we have there, which is correct. So when you multiply this and this together, you have negative 24. And when it's added together, we have plus 2. So that means that we divide these 2x into 2 parts. So let's do that now. So we have 0 equals to, right? If you wish to put your 0 here, it's not the same thing. Okay, let's do that because since you are quite familiar with that. So we have x squared negative 4x plus 6x negative 24 equals to 0. Okay, so you can either put your equality here or here. All right, so now let's look at the first pair here. All right, what's the GCD of these two terms? So we have x. So when you divide this by x, x squared divided by x, we have x. Negative 4x divided by x, we have negative 4. So we do the same thing here. The GCD here is what? That is 6. So when you divide 6x by x, we have x, and negative 24. That's negative 4 equals to 0. Okay, so now let's factor out what we have in the bracket. So we have x minus 4, x plus 4 plus 6 equals to 0. Right? So two numbers are multiplying each other to have 0. So it's either x minus 4 is 0 or x plus 6 is 0. Okay, so here, let's add 4 to both sides. So we have x equals to 4, or here, subtract 6 from both sides, we have x equals to negative 6. So these are the roots of this quadratic equation. So I want to believe you all understand that. Okay, so yes, I have another interesting question which I want you to pay attention to. If negative 3 is a root of the equation x squared plus px minus 21, find the other root. Find the other root. Okay, now look at this question. Now, if negative 3 is a root of the equation, this quadratic equation, okay, right? Okay, so I think this should be equal to 0 because this is an expression. Okay, you have to find the other roots. Now, we should have it at the back of our mind that whenever you solve quadratic equation, you have two answers. I want to believe you know that. Now, you can see this quadratic equation we solved here, we have two answers. So we have been getting two answers. So now this question is telling us that there is a quadratic equation which we have here. One of the roots of the two equation, one of the roots of this equation is negative 3. So we have to find the second root. So how do we go about this? Now, so there are several ways you can approach this problem. But let's use this approach. Let's see how we're going to get the answer. Now, we can start by saying, let's the other roots, which we are looking for now, other roots be equals to, let's say a. The other root is a. So that means we now have the two roots here now. So we have negative 3 and a, which we don't know, right? So now if these are the two roots of this quadratic equation, so that implies that x is negative 3 or x equals to a. Do you agree with that? Okay, so that's what we're going to have because these are the roots, the answers to this quadratic equation. So we can move this, let's transpose. We have x plus 3 equals to 0 or x minus a equals to 0. Now we can bring this and this together. Now let's bring them together. We have x plus 3, x minus a equals to 0. Okay, so the next thing is to expand. Now to expand, this x will multiply the x here and also a here. All right, can we expand now? So x times x, we have x squared. Now x times negative a, we have negative ax. Now the next thing is the 3 we have here, multiply x and also multiplies negative a. So 3 times x, that is plus 3x. Now, the next one is 3 times negative a. That is negative 3a. Okay, equals 0. Can we see that? Okay, so now we can write this as x squared. Now, I'm trying to compare with this because what I have here now is going to be the same thing with the equation here. All right, so we have plus negative a plus 3x negative 3a equals 0. So this equation and this equation are the same thing. All right, because the root of this quadratic equation are negative 3 and a, which we make an assumption earlier. Okay, so and once you use it to form an equation, it must give you this. So it means that this equation is equivalent to this. So we can just make some comparison. So right, so now if I want to do it now, I can compare this and this. Can you see that now? So negative 21 with negative 3a. So we have negative 3a equals to negative 21. And you can go ahead and divide both sides by negative 3. So we have a equals to negative 21 over negative 3. So the other root is going to be 7. And that is the answer to the problem. I want to believe you understand that. Okay. Suppose the question now is asking for P. Now P is this. You can see where we have P here. This is plus, and we can see plus here. So what we have here now is the same thing as P. So you equate it. So we have P equals to negative a plus 3. And the P is negative 7 plus 3. So P equals to what? That's negative 4. So P is negative 4, while the other root is A. All right. I want to believe you get that. All right. Okay. So we are moving down to another question straight away. So, but I want to employ those of you that are joining us for the first time. Don't forget to tap the like button and also subscribe to this channel. All right. Okay. Thank you for doing that. So let's look at this question. X squared over 5 minus 6x over 5 plus 1 equals to 0. Okay, so now I've solved this type of problem in the last video I made. So let us see how you're expected to solve this type of problem. Now look at this quadratic equation with fraction. The first thing is to clear the fraction. How do you clear the fraction? You look at the denominators and find the LCM. So you multiply each of these terms by the LCM of the denominators. All right. So the LCM of the denominators here is what? Is 5. Okay. So that will help us now to clear the fraction. So you multiply each of them by 5. So LCM is 5, the lowest common multiple. So we have 5x squared over 5 negative 5 times 6x over 5 plus 1 times 5 equals to 0 times 5. Okay, so now 5 will cancel 5 here, 5 cancel 5 here. So what we are left with now is x squared negative 6x, okay, Now plus 5, because 1 times 5 is 5. So equals to 0. 0 times 5 is 0. So this dot means multiplication. Okay. So now the next thing is to find a way of factorizing this quadratic equation. So I need you to tell me what is going to be two numbers that will be needed here for negative 6x, negative 6x. What are the two numbers? So can you smartly do that and drop your answer in the comment section? Okay. I don't want to write the sum and product so you know what to do. So now just give me the two numbers. All right. So let's see if we can do that very fast. Okay. All right. Good. 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 Yeah. Okay. Yeah. Dupe, I can see. Okay. I think I'm seeing Dupe for the first time. Okay. And all right. Okay. Okay. Yes, you guys are doing very fine. Very fine. Okay. So the two numbers needed here are negative 1 and negative positive 6. I think that's what we have. Okay, is that what we're going to have now? Or let's say negative negative 5. Okay, so these are the two numbers. When you add these together, you have negative 6. When you multiply together, you have positive 5. I want to believe you all understand that. So there are some of you now that didn't get this answer. So do you get it now? So negative 1, negative 5. Add this and this together, you have the sum, that's negative 6. You multiply these two together, you have positive 5. All right? Good. So that means this equation turns to x squared negative x negative 5x plus 5 equals to 0. So that's what we have. All right, so the next thing is to look for the GCD of this pair. So what's the GCD? The GCD is x. So when you divide each of them by x, you have x minus 1. Yeah, what's the GCD here? So that is negative 5. So when you divide this by 5, you have x minus 1 equals to 0. Okay, so you can factor out x minus 1. So you have x minus 1. You are left with what outside here? You have x minus 5. So x minus 5 equals to 0. So two numbers are multiplying each other now to have 0. So it's either x minus 1 equals to 0 or x minus 5 equals to 0. I hope you understand that. Okay, good. So now here you can add 1 to both sides. You have x equals to 1 or x equals to what? 5. So these are the answer to the problem. All right. Okay. Yes. This last one that I have here is going to require a lot of attention. So let's look at the problem. So we have x plus 1 over x raised to the power of 2 minus 5 x plus 1 over x plus 6 equals to 0. All right, so how do we solve this problem? Yes, now to solve this problem, you don't need to look at the problem as if it's hard. You have to get the trick behind it. Now, when you look at what we have here, this has the power of 1, 2, sorry, and this has the power of 1. And you can see what we have here, the base we have here is the same thing as the base we have here. So to work with this smartly, what we are going to do, you start by saying, let x plus 1 over x be p, right? So that will make this equation to be simple. So I have it as p squared minus 5p. Okay, so this has turned to p. This is p squared plus 6 equals to 0. Can you see that? So you can see how we have reduced this giant equation to this. All right, so now the next thing is to solve this quadratic equation. So how do we solve that? The sum and product. I know you'll be thinking of 2 and negative 3. It works. When you multiply, you have plus 6. When you add, you have negative 5. Okay, so now this turns to p squared minus 2p minus 3p plus 6 equals to 0, right? So now you find the GCD of these two terms. So the GCD is p, we have p minus 2. Now what is the GCD of these two terms? We have negative 3. So we have p minus 2 equals to 0. All right, do you understand that? So the next thing is to find the GCD of these two terms here, and that is p minus 2. You have p minus 2, and you're left with what? P minus 3 equals to 0. Okay, so I hope you understand that. So we have two numbers multiplying each other now. So you have p minus 2 equals to 0, or p minus 3 equals to 0. So we have p equals to 2 or p equals to negative 3. All right, so the question has been half solved. So we are not asked to find p in the question. We have to solve for x because the equation is in terms of x. So, but don't forget we have made an assumption that x plus 1 over x to be equals to p. So let us incorporate this back here. So that means we have x plus 1 over x equals to 2, or x plus 1 over x equals to 3. Now let's work with this. Now what are you going to do here? You multiply by the LCM of the denominators. So this is over 1, this over 1. So the LCM of the denominator is x. So multiply this by x, and this by x. So we have, when you multiply x by x, you have x squared plus multiply this by x. We have x here. So x will cancel x. So you have what? 1 equals to multiply 2 by x, we have 2x. So let's bring it here. You have x squared minus 2x plus 1 equals to 0. Okay, can we solve this now? So the two numbers are negative 1 and negative 1. Okay, so so this equation turns to x squared negative x plus 1 equals to 0. Okay, so what is the GCD of these two terms? That is x. So you have x minus 1. Okay, and this, the GCD is going to give you negative 1. That's x minus 1 equals to 0. So you can factor out this. So you have x minus 1. You are left with x minus 1 here as well equals to 0. Okay, so we have x minus 1 equals to 0, or x minus 1 is 0. So that means x equals to 1 twice. So that's going to be the answer. Okay, so x equals to 1 twice. So that's the first part. Now let's look at the second part. Yes, you have this equation. So you multiply this equation by the LCM of the denominator, the way we did here. So you multiply this by x, this, and this. So we have x squared plus 1 equals to 3x. So when you multiply through by x, so and that is the same thing as x squared negative 3x plus 1 equals to what? Equals to 0. All right, so now what are the two terms? Can you do that for me? The two terms, the addition is 1, is negative 3, and the multiplication is plus 1. Okay, so can you tell me what that is going to give you? All right, what is it going to give you? Now, by the time you solve this, you are going to be having a complex solution. It's going to give you a complex solution because the discriminant d must not be less than 0. Once it is less than 0, so that means the solution of this is going to be a complex number. So what is the discriminant? That is b squared minus 4ac. All right, so b is this. So that is negative 3 squared minus 4 times 1 times 1. Okay, I think it's going to be greater than 0. So that means the solution will exist, but it's going to be a decimal. Okay, so that means we have 9, and this is going to give us negative, what have you? That is negative 4. So we have 5. All right, so now the discriminant is greater than 0. So once it is greater than 0, it means the solution is going to give us a real number. So we can then make use of the quadratic formula to solve, or use completely the square method. Okay, so now let's do that. Okay, now, so this one is just to verify if this equation is solvable or not. As you can see now, it's solvable because the discriminant must be greater than 0. So, and this is actually greater than 0. So let's see. So let's plug in the value into this. X equals to negative b plus or minus square root of b squared minus 4ac over 2a. All right. So now when you look at this equation now, a is what? Coefficient of x, that is 1. B is what? Negative 3. And C is the constant here, that's plus 1. So we just plug in these values into this equation. So that will give us the idea of what the solution is. All right. So now can we plug in the values down? We have x equals to negative 3 plus or minus square root of negative 3 squared minus 4 times 1 times 1. Everything all over 2 times 1. Okay, do we get that? So what is the next thing? Let's simplify. So we have x equals to 3. That's minus times minus is plus. So we have plus or minus square root of. Now when you square negative 3, you have 9. 9 minus 4. Okay, everything over 2. Okay, do you understand that? So now we have x equals to 3 plus or minus square root of 5 over 2. Okay, so that means the roots of this quadratic equation will be x equals to 3 plus square root of 5 over 2, or x equals to 3 minus square root of 5 over 2. So the answers are 1 twice, x equals to 3 plus square root of 5 over 2, or x equals to 3 minus square root of 5 over 2. All right, so that is how to solve this type of problem. All right, so I want to believe you all understand that. Okay, now I'm moving down to another question or another topic, that is approximation. So Let's look at one or two questions there before we leave for today. Okay, all right. So this is another topic, approximation. I want to believe you guys love this topic very well. Okay, drop your thoughts about this topic. What's your impression about this topic? Now let's look at this problem. Now the length of a top table is measured to be 100 meters. So you have to find the percentage error if the length is measured to the nearest meter and B to the nearest two significant figure. Okay, so solution. Now you have to find the percentage error. Now to the nearest meter. Now when you look at it, we have 100. The nearest meter now, the position of the nearest meter is 6, and that is going to be at units. Okay, nearest meter is here. That's units, unit position. All right, so now error is going to be plus or minus the units divided by 2. Okay, and that is going to be 0 plus or minus 0.5 meters. I hope you understand that. Okay, to the nearest meters is to the nearest units. All right. So now to get the percentage error, we have percentage error is the absolute error over actual value times 100%. So that's what we have. Now the error is the absolute value of plus or minus 0.5 is 0.5. Everything all over. The actual value is 100. Okay, times 100%. Okay, so this cancel this. So the answer is 0.5%. So that is the percentage error. That's all. Now let's look at the next one, B. Now you have to find the percentage error to the nearest two significant figure. Now two significant figure is on what position? Let's look at it. 1, 2. Two significant figure. This is the first significant figure in 100 meters. Look at it, 100 meters. The first significant digit is 1, while the second is 0 here. And the position value of this 0 is tenths. Okay, is tenths. So that means that error will be equal to tenths. That's 10 over 2, plus or minus 10 over 2. That's plus or minus 5 meters. So that is error. So we can get the percentage error to the nearest 2 SF. So we have percentage error will now be absolute error, that is 5, over actual value, that is 100 times 100%. So this cancels this. So we have percentage error is 5%. So this will be the answer to the problem. You can see it's pretty simple. All right, good. So now let's look at another interesting question. Okay, yes, this is another question. Now let's look at this question. Now a square is 10 meter by 10 meter in dimension. If a student measures a side of the square as 9.5 meters and uses the measurements to find the perimeter of the square, find the percentage error inside and in perimeter of the square. All right. So now we know the actual dimension to be 10 by 10. Sides of a square are equal. The sides are equal. Sides of squares are equal. All right. So now let's see the error made by the students. He measured one side as 9.5. That means he is saying that all the sides are 9.5 meters. Okay, so now let's get the percentage error in length. So we say error in length, that is length of the side, that is going to be 9.5 minus 10, and that's going to give us negative 0.5 meters. So this is the error made by the students. Okay, so let's get the percentage error inside. So percentage error in length of the side is going to be the error negative 0.5 over the actual length. That is 10. We have 10 times 100%. Okay, so this cancel this. So when you multiply this and this together, you have negative 5%. So that is the answer. So I want every one of you to pay attention to this. Okay. All right. So now let's look at the second part of the question. We have to find the percentage error in the perimeter of the square. So how do we go about this? So now the first question I ask myself is, what is the formula for finding perimeter of the square? So perimeter of the square is 4L. All right. So that means actual perimeter will be what? 4 times L. So L is the side, and that's 10. So that gives you 40 meters. All right. So estimated perimeter, that is the perimeter calculated by the student, that's going to be what? 9.5, or 4 times what? 4 times 9.5. So, and that gives you what? So let's reduce that. That's going to give you 39.8. So that's what we have, 39.8 meters. Okay, or we say, okay, that is okay, that should be 38. That should be 38 meters. Okay, so that's what we have. Okay, so now you can see the error made by the student, 38 meters. Okay, so now let's get the percentage error. So percentage error in perimeter. Percentage error in perimeter now is going to be what? 38 meters minus 40 meters. And that gives you what? 2 meters. So that is going to be the percentage error. Okay, that the sorry, it's not the percentage error. Sorry, I beg your pardon. So that's supposed to be the error in perimeter. Okay, so we have to calculate the percentage error now. Okay, so what is going to be the percentage error? So percentage error is going to be the error, that's 2, over the actual perimeter, that's 40 times 100%. Okay, so that's 100%. I hope you understand that. And let me go through it again. This is the actual perimeter. So, and this is the formula for perimeter, 4 times a side of the square. So that is 4 times 10. It's given in the question, that's 40 meters. Okay. All right. So the estimated perimeter, and that is 9.5. That was the measurement taken by the student. So times 4, that is 38, right? Meters. Okay. So now error in perimeter, that is error made by the students in calculating the perimeter of the square. So it's going to be 38 minus 40. That is 2, or we say negative 2. The sign is immaterial. Okay. So, or negative 2. So now this is now the percentage error. So error over actual value times 100%. So 0 cancels 0 here. Okay, so we have 20, 10 times 2 is 20 over 4. So the answer is going to be 5%. All right, so I'm just going to give you one question to try. It's a very simple one. So it seems I've been the only person working since. So now, can we do this? Find, or let's say convert, convert 1/8 to two significant figures. Okay, so can you do this one and drop your answer in the comment section? Let's quickly try this one. Convert 1/8 to two significant figure. Can you quickly try this? All right, do that smartly and drop your answer in the comment section. Let's see what we have. Yes. Okay, Ajibola, you can drop your answer. Yes. Okay, someone have dropped an answer. Christiana have dropped an answer. 0.01. 0.01. Okay. 0.01. Okay, I know. Oluke, yes, 0.01. Please ensure you are not following the crowd. Ensure you don't follow the crowd. Make sure you know what you're doing. Okay. Yes, I'm waiting for others to drop their answer. Yes, 0.125, 0.01, 0.13. Okay. All right. Mujisola. I can see Christina dropping. Yes. Joseph. Okay. Show me the. Yes. Ajibola. I can see your answer. Okay. All right. Okay. I think we have different answers this time around. Okay. Yes, I can see Okoyemi. I can see Okoyemi. Drop your answer. Let's see what do you have. Yes, progress. I can see 0.1. Okay. Okay, good, good. We are all doing fine. We're all doing fine. But now let's see. And let's quickly do this together. Now, the first thing now is to convert. I'm solving it now. 1/8, you convert that to decimal. That's going to give you 0.125. Now, you have to correct to two significant figure. Now, when I say significant figure, is the first significant figure must be a non-zero number, non-zero. Okay, so I can't start with 0 here and call this a significant figure. No, this is not significant. It's just like if I have 7 and I put 0.7. This 0 is not significant. All right? But if the 0 were to be here, then it's going to be significant. All right? So this will change 7. 0 here changes 7, but here doesn't change it. Does not change it. Okay? So now in this case now, this you can't start counting from here. You start from here. You count 1, 2. So this is what you are writing out. But then if the next digit to the last count is up to 5, you have to increase your last digit by 1. So in this case, your answer is going to be 0.13. Right? So I want to believe you all understand that. Please ensure you pay attention to this. Many students make mistakes when doing this kind of problem. All right. Okay. Now let me give you another one. Let's quickly do this to be sure that every one of you understand how to convert number to significant. All right. To convert 4382 to two significant figure. Two significant figure. Yes, can you see that? 4,382 to two significant figure. Yes. Can we begin to drop our answer to that? Yes. So what is the answer to that? All right. Okay. Adiomi, I can see that. Okay. That's 4,400. Yeah. Okay. Yes. And you laugh for the 4. That is interesting. Okay. Right. Okay. Show me the 44. 4,004. Okay. Yes. Familiar. I can see 4,400. Okay. Next one for the 4. Yes. Taiwo. 4,400. Okay. Yes. Christina, I can see your answer. Okay. 4,400. Any other different answer? Anyone? Okay. So I think we can do this together now. All right. Yes. Solution. We have 4,382. You want to convert this to two significant figure. Now, you start by counting the first non-zero digit, which is 4. You count 1, 2. So after counting, this is the count. But then you look at the next digit, it is up to 5. So if it is up to 5, you increase this. So that means we have 4, 4. But I will not just leave my answer this way, because these two digits are before decimal point. So I will turn them to 0, so I have 0, 0. Okay, so the answer to this problem is 4,400. So I want to believe you understand that. Okay, the last one. Can you do this? Okay, you have to convert this to two significant figure. All right, two significant figure. Two significant figure. Okay, 2 SF. Okay, let's convert this one to 2 SF. This number, what do you have? 2 SF. Okay, 2 SF. What do we have? Yes, you know the answer drop. Okay, I know. Okay, I can see that. Okay. Wow. Okay. All right. I can see that every one of you have the same answer. Okay, good. So this time around, I think every one of you got the answer. Okay. So now 2SF, count 1, 2. So this is what you are writing out. So, but since the next one is up to 5, so you increase this by 1, that's 84. Now, don't make a mistake. Many students make this mistake, but I'm so happy that you didn't make that mistake. Now, they begin to turn the remaining digit to 0. You don't turn digits after the decimal point to 0. Don't turn them to 0, okay? So the answer is simply 84. 84. So that is the answer to the problem. All right. So yes, I want to believe you guys have learned one or two things. So I'm so happy and I'm excited that you guys are doing fine and you contributed so much to this class. Yes, we're going to be stopping here today. So if you are new in this channel, don't forget, ensure you subscribe to this channel. And if you have not given the class a thumb, make sure you do that. Okay, so, and I also want to encourage you to always visit some of my videos. I've done a lot of videos on quadratic equation and approximation. You can always learn one or two things. And once you view the videos, ensure you share with your friends, and so that many people will know about what we do here. All right. Okay. So tomorrow is going to be another wonderful time. We're going to have other questions. So I'm going to be treating some questions on approximation, and also on logical reasoning. So I'm going to pick one or two questions under logical reasoning, and also variation. So we are going to look at one or two questions on that variation. So these are the things we're going to look at tomorrow. So make sure that get yourself ready for tomorrow's class. Thank you so much for watching. I love you guys. Bye bye.